Okay, then let's start with week number 3. Just give me a moment, I'll share my screen. Okay, is it visible?
Yes.
Oh,
Yes, sir.
okay, so this is week number 3. And before we go into that, any questions from the previous week's content? Okay, nobody? Then let's proceed. Yeah, week 3. And this is the moment where we learn about moments. Right, so we started with the first order moment, which is generally called mean or expectation, right? And the definition is pretty easy. It's just integral of x times f of x dx, where this small f of x is the probability density function. Yeah. And in a discrete version, this would be like sum over xi times f of xi, right? That's it. We use small p for the discrete one. So let me make it small p. Okay, so what we are saying is basically take a weighted average of this x's, and that would give us the average of all the x's given the probability distribution p. Okay, but what we also learned, and this is the central theme of this week, is that statistics does not mean what is happening at the center. Equally important is how spread it is, how spread your distribution it is. For example, we can say median income of India or mean income of India is this much rupees. I don't know, 10 lakh per year or something like that, maybe lower, but that doesn't tell us much. It's possible that many people are Ambanis and many people don't have home, which is what the case is. Or it could be that most people are very close to that 10 lakh or whatever the mean is, which would be a better scenario. So we need to know how distributed the function is, how spread it is. Okay, which is why we define higher order moments. So that is where the concept of variance comes in, and that is defined as expectation of x minus mu whole square. Right. So we know that x itself is a random variable. So x minus mu is another variable, random variable, and we can take function of that variable. So function of a random variable is also a random variable. We learned that, right? As long as it is piecewise continuous, which this is. So we can take expectation of that. And this is defined as variance of x, where mu is just the mean. By the way, if you have any questions, please ask me right away. Okay.
Expectation expectation is mathematically, if it is summation, how it represents the mean?
How it represents the mean? Okay, that's a very good question. So let's look at some high school questions just to get some idea. Let's say I have different students in a class, and I'm measuring their heights. Okay, I don't know which units we should be using? Okay, maybe, yeah, in feet. So some are 5.2, some are 5.3, some are 5.4, some are 5.5, some are 5.6. Okay, then if I ask what is the average height of this class, first thing that might come to our head is to just take sum of all these numbers and then divide by 5, right? So 5.2 plus 5.3 up to 5.6 divide by 5. But would this be average? And then answer is no, right? So what could happen is that there are many children which have height 5.6 and very few which have 5.2. And then the average would be this way. Okay. So let's say the distribution looks something like this. So if you take direct average like this, then the answer would be 5.4. But you can see now that the answer should be more than 5.4. So how do you account for that? So we say that the every height is associated with some probability. So let's say this is height x1, x2, x3, etc. Okay, and then every height has some number of students. So n1, n2, n3, n4, n5. Okay, so what we have learned is that average is total height, yeah, divided by total number of students. Okay, what is the total height? That is 5.2 times the number of students with height 5.2. So n1, right? Yes, plus 5.3 times n2, etc. Okay, so n divided by total number of students would be
Sigma n.
n1, yeah, sigma n. So I can write x1 n1, x1 n1 plus x2 n2, right? Divided by n1 plus n2. So let me call it n, where n is sigma ni. Okay, and now what I do is simply divide the denominator. So I write x1 into n1 by n plus x2 into n2 by n. Can I do that? Yes, I can. Now what is n1 by n? That is the fraction of students with the height n1, which is nothing but the probability of a random student having that height. So I can write x1 times p1 for p of x1 plus x2 times p of x2, right? All the way up to how many intervals are there. So this is how we get summation over xi p of xi. Okay, which is exactly the formula is, right? This one. Is
Okay,
it
nice.
clear?
Good. Okay,
Yeah.
okay. Yes, yes.
Okay. And the next question would be, how does this translate to this formula? You can think about it. It's basically just multiplying. So we are saying that p of xi is the probability of xi. We should replace it to fx dx, and we get that continuous version. All right. Okay. Then let's move ahead. Okay. So now we understand variance. Let's look at the formula. What it says is that how much far you are from the mean. X minus mu is how far you are. It could be negative or positive, but we just want to know the average distance. So we square it. So it is always positive. Okay. So on average, how far you are, or rather square of how far you are, that is the variance of x. If it is small, that means that your distribution is narrow. So if I plot f of x versus x, if it is something like this, then this variance would be low. On the other hand, if it is spread, something like this.
Mu is deviation, right?
Mu is the average value, expectation.
Okay, average.
Okay.
Okay, okay.
Okay. So in both the cases, this central line, this is our mu, right? So here all the values are very close to mu. So the variance would be low. But the yellow one values are farther. So variance would be higher. Okay. So this is the meaning of variance. And this also tells us why variance is important because both of them have same mean. They are centered around the same position, whatever it is. Maybe it's 5. So if I say that average height is 5.2, it doesn't tell us how far people are, how spread that distribution is, right? So which is why variance is important. And as we will see in statistics, even higher order moments are also important. So the next one is called, I think, kurtosis or something like that. Maybe it's the fourth order. We'll learn about that as well. Okay. And so we had some properties. So for mean, that is expectation. One important property was that it's a linear function. So if I multiply a with the random variable x and add some real number b, that's same as a times expectation of x plus b. Okay. Uh, the other one was if I have just a constant number, then its expectation is also alpha. What I'm saying is that height of every student in the class is 5 feet. Then the average height is also 5 feet, right? Pretty trivial, but needs to be mentioned. Okay. Then let's say that height of every student is greater than 0, which is true. Then the average height would also be greater than 0. Okay. And the fourth one was, yeah, one important one, that if I have a function of a random variable and if I know the average or the expectation of x, then I can calculate the expectation of y as well without explicitly calculating what this function is, or rather what's the distribution of x. And the way we do is that e of y is given by integral of hello, am I audible?
Yes, sir.
Yes.
Sorry, something happened. Let me share my screen again. Okay. Yeah. So now variance the probability. Firstly, if I do a times x,
Screen is not visible.
yeah, sorry, it's cut off. Is it visible now?
Yes, sir.
So you're mute.
Okay, am I audible now?
Yes.
Yeah.
Hello, hello.
Yeah, you are audible. But screen has gone again.
Is the screen visible?
Oh, yes.
Yes, sir.
Yes. And am I audible? Okay. Okay, let's continue. I don't know what happened. Uh, yeah, sorry about that. It was actually Institute's Wi-Fi. You would think that IIT's Wi-Fi would be good, right? IIT being Indian Institute of Technology. That's certainly not the case. Anyway, so sorry about that. Let's continue. So about variance, yeah. Uh, so another property is that variance of any random variable would be greater than zero. In fact, equality holds only if it's a constant, right? If it is a constant, it means all the probability is at located at the same place, some alpha. So there is no variation in X. In some sense, it's not random variable, so to speak, because we know the value of that. Okay, so this is if and only if condition. And yeah, that's it. So then we can similarly define any higher order moment. So we define mu n as expectation of x minus mu to the power n. Okay, so for example, mu1 would be simply 0. Why? Because it is equal to expectation of x minus mu, which is because expectation is linear, expectation of x minus mu, which is just mu minus mu, which is 0. Okay. Mu2 is the expectation of x minus mu square. Okay. So the square is variance, which means mu2 is variance. And so on and so forth, we can define. So this is defined with respect to the mean, the central value. We can also define without the mean, which we denote by mu n prime or mu n dash, which is just pure vanilla x raised to n expectation. Okay. And there was this theorem which related this mu's. Let me find it. You can find them in the notes. Yeah. So there was this nice theorem that mu n is equal to sum over n c k mu k prime and minus mu 1 prime, which is just mu raised to n minus k. Okay. So this relates higher order moments to the lower order moments. And all this discussion makes sense only if they exist, right? So I should mention, I forgot to. This is only if integral of mod x f of x dx from minus infinity to infinity, that is less than infinity. So if it is finite, only then we define expectation. Okay. So whenever we say a statement something like this, it means we are defining it only if it exists. So that is something that is implicit. And we had done some examples, but let me just show you one example, which is very important. And I think we are going to see that again and again in the course, which is this distribution. Sigma root 2 pi. Yeah. E raised to minus x minus mu square divided by 2 pi 2 sigma square. Okay. And if we plot this using Desmos or any of your favorite tool, then you will see it looks something like this. Okay. And it is centered around this number mu, which is the mean. And standard deviation, this is sigma. Okay. Which tool you mentioned to plot? That's called Desmos. It's a very nice tool. Okay. It's an online tool, or there is an app also which you can use to plot various things. Okay. Then we looked at inequalities in moments. Enough with equalities. Let's look at inequalities. So first one was Markov by.
So sorry to
what it says is that probability of x greater than or equal to t as an upper bound. So at max, it could be expectation divided by t. So we have this assumption, right? That x be a random variable with probability of x
Sorry to
greater
interrupt.
than or equal to 0 being 1,
see that graph
which
again.
means x is always positive, or rather almost always positive. So when x is positive, we can use this result. It's a very nice result, but let me just give a quick intuition behind this. Proof is anyways given in the note, so no point repeating it. So the idea is that we have some probability distribution. This is 0, this is x, this is f of x. Okay. And it's something like this. Could be something. And we are interested at some value, which we are calling t. And the question that we are asking is, what could be at max the probability that x is greater than t, which means this area. Okay. And let's say mu is somewhere here. So this is mu. So for example, the probability of this cannot be 1. Why? Because if all the mass is here, then the mu would also be here inside this, which is not the case. So it cannot be 1. So could it be 0.98? Could it be 0.98? There is some maximum value which it can take. What could be that maximum value? And for that, imagine that again you have some kind of mass that is given to you, 1 kilogram of steel, and you want to distribute it over this infinite scale, but of course it has to be greater than 0. So you cannot go in the negative side. So what is the maximum mass you can have here such that the mean is still at mu? Okay. And so can you scroll? Graph देखना था. Is it not visible? Oh, this graph. You mean?
Yes, sir.
Okay. Yeah, this is the standard Gaussian or normal curve. Okay. Yeah. Okay, so we were talking about intuition behind Markov's inequality. And so we are given this puzzle that we can distribute mass whatever way we want. Only constraint is that the average value of that mass, the center of mass, so to speak, should be at this point. So how much at max can you distribute beyond t? Okay, so you say that as I can distribute some fraction of stuff. Let me call it, I don't know, f. Okay, so some part f, which could be 0.7, 0.8, that is the maximum I can distribute. And where should I keep the rest of the mass? Well, I should keep it exactly as 0, right? Because that way I can have the maximum mass here without disturbing the mu. If I put it here, let's say 1 minus f somewhere here, then I can argue that if I shift this mass to 0, then I can still have more mass here. Okay, so the best chance is to have all the mass here, all the rest of it, which means now let's take average of this two. So here the average is 0, right? Everything is 0. And the fraction of mass that is there is 1 minus f plus how much mass is here? That is f times the average of these points, which could be anywhere. So let me call it t star, which is greater than or equal to t, right? This is t star. And this average should be equal to mu. And so given that t star greater than or equal to t, what is f max? That is the question, right? So if I solve it, this is just 0. So f is equal to mu by t star. And t star is greater than or equal to t, which means f is less than or equal to mu by t. Okay. In our original language, this was probability that x is greater than or equal to t. And mu was the expectation of x, and t is still t. Okay, so that's sort of the intuition behind Markov's inequality. And we'll do one question about this, so this will be clear. So even if you don't know Markov's inequality explicitly, you can still solve the problem using this equation. Okay, then the second one was Mr. Chebyshev. Okay, and what it says is that probability that mod x minus c is greater than or equal to epsilon. So probability that x is farther from some number by at least some unit epsilon, that is less than or equal to x minus c square, expectation of that, divided by epsilon square. And if we put c is equal to mu, then probability that x minus mu greater than or equal to epsilon, that is less than or equal to expectation of x minus mu square, which is nothing but variance. So that is variance of x divided by epsilon square. Okay. And in this, we can still apply the same kind of intuition But the best way to see this is to replace x by x minus mu square in Markov. Okay, so that's the intuition. And even graphically, you can think about this. So you have some distribution, need not be normal, by the way, but you have some average value. So if you go too far from that, you cannot have too much probability there, right? Because again, mean is somewhere here and variance is also given to be some value. Okay. So what it says is that there is a upper bound or maximum value of the mass that could be here, and that is given by this number. And as you can see, it's inversely proportional to epsilon. So if I look farther, I can have lower maximum possible value of the mass that is contained here plus here. Okay, so that's the idea. And the third one is Jensen. Yeah, this is interesting. It says that expectation of g of x would be greater than g of expectation of x if g is convex. Now the professor did not mention what does function being convex mean. So some of you may not know, but you must have seen in science or physics that we have convex lens which looks like this, right? So in the same spirit, we can define a function, or we can classify whether it's convex or not. So if it looks like upward curve, something like this, then this is convex. Okay. Sort of a happy smiley. And if it is downwards, then it is not convex. Okay. So for instance, y is equal to 1 over x. So this is curving upwards. Even though it never goes upwards, you can still see that it's part of this happy smiley. Okay, so it's convex. But y is equal to minus x square. Okay, this is sad smiley, so it's not convex. So if it is continuous, then what we can say is that derivative of this function dgx by dx. So that is the slope. So here the slope would be, let's say, minus 5. Then this slope is decreasing in value. So it becomes minus 2, then minus 1, goes to 0. So the value itself is increasing from minus 5 to minus 1. So if I take second derivative, that is the rate at which slope is increasing, that is always positive. Okay, so this is the definition for a continuous differentiable function. And in general definition is that g of alpha x1 plus 1 minus alpha x2. So let's look at 2 points here. Let me make another graph. So I have one point which is x1 and this is x2. And if I join this line and I'm looking at somewhere in between, so if it is exactly at the center, alpha would be 0.5. But in general, if this is 1 minus alpha and this is alpha, then this point would be alpha x1 plus 1 minus alpha x2. Okay, so this is that value of function at this point, which is this g of alpha x1 plus 1 minus alpha x2. And this point lies below this point, which is if we add a linear graph. So this is always less than or equal to alpha times g of x1 plus 1 minus alpha times g of x2. Okay, this is the most general definition of a convex function. And even if you don't remember, just remember this happy face. Okay, for example, y is equal to x square. upward parabola that is convex. So let's apply that itself. So let's apply g of x is equal to x square. Then we get what was the inequality? Expectation of g of x. Expectation of g of x greater than or equal to g of expectation of x. So I get expectation of g of x is x square greater than or equal to g of expectation of x square, which means expectation of x cos square, which is mu square, which means expectation of x square minus mu square is greater than or equal to 0, which is why we get variance of x greater than or equal to 0. Okay. So as you can see, this is a very general statement. G could be x raised to 4 or anything. As long as it is convex, we get different inequalities for different function. Okay. And the last inequality, fourth one, was that we defined beta n as the expectation of mod of x to the power n. So instead of x to the power n, we just like look at the absolute value of x. Then we have beta 1 raised to 1 less than or equal to beta 2 raised to half, beta 3 raised to 1 by 3, etc. Okay, all the way up to beta n raised to 1 by n till the point where we can define these betas. Okay, so it could be possible that beta n plus 1 is not defined. So we cannot extend the equality. Okay. So any questions so far? Anybody? Okay. If not, then let's look at the final topic, which was generating function. So the way I look at generating functions is that we have all the information that is needed for a problem in the distribution function, right? But we can equally define different functions which also has the same kind of information. So every information that is contained in distribution function is also contained in this generating function, but they come with some added benefits, as in we can calculate moments easily, etc. Okay, which is why we are studying. So the first one is PGF, probability generating function, defined only for non-negative integers. Okay. That is x is equal to 1, 2, 3, etc. Okay, if that is the case, then let's say p of xi or xk, we denote it by pk. Then the probability generating function, which is a function of some variable s, is sum over pk s to the power k. Okay. And I have to keep mod s less than or equal to 1 so that this does not diverge, where k is equal to starts from 1 to infinity. All right. And then we can easily see some properties. For example, if I put s is equal to 1, then it is just sum over all the probabilities, which is obviously 1. Okay. Another is that gx of s is nothing but this function s raised to k weighted with pk. So we saw that expectation of any function is that function multiplied by the probabilities. So this is nothing but expectation of s raised to x, right? The third one was if we differentiate g r times. So let me calculate first the first derivative, right? So that would be sum over pk, and then I have k times s raised to k minus 1. That's the derivative of this, right? S raised to k. That comes here. Okay. If I take second derivative, then sum over pk k into, now exponent is k minus 1, s raised to k minus 2. Okay. So this I can write as expectation of x into, sorry, this is just expectation of x. This would be equal to expectation of x into x minus 1, etc. Okay, so in general, gxr of s would be expectation of x minus 1 all the way up to total r terms, so x minus r plus 1. Okay, and the final property, which is that I can recover the coefficients from a series. Okay, this pk. So I want to find gx from pk. I use this formula. But now I am given this gx and I want to find probability that x is equal to 2026, for example. So how do we do that? So let me first give the intuition. So I have gx of s is sum over pk s raised to k. Let me write it explicitly. So p1 s raised to 1, p2, sorry, it starts from 0, right? It's non-negative, so it could be 0 as well. So p0 plus p1 s plus p2 s square plus p3 s cubed, etc. Okay, so we have a series and I want to find what is the value of p3. If it is given in this term, then I can directly say it's the coefficient of s cube. But maybe it's given in terms of some other function, maybe sin x. Okay, so how do we calculate this? So if I put gx of 0, then this is 0, all these terms are 0, so I get p0. If I want to find p1, then I can differentiate it. So g prime s becomes p1 plus p2s plus p3, sorry, 2 times p2s plus 3 times p3 s square, right? If I differentiate it again, second derivative, then I get 2 times p2 plus 3 into 2 times p3 s, etc. Let me differentiate at least once more. So third derivative, that would be 3 times 2 times p3 plus this p4 into some number here, s raised to 1, etc. Okay, so now I put s is equal to 0 in all of this. So all these terms are cancelled. So I get p1 here, I'll get 2p2 here, 3 times 2 times p3, I can put 1 here, right? So in general, c x differentiated r times would give me r factorial times pr, which means pr is nothing but differentiation of g r times divided by r factorial. Okay. Evaluated at s is equal to 0, because we have to put s is equal to 0 at the end. All right. The second generating function was a moment generating function, mgf, and that is defined as mx of t, where t is any real number, expectation of e raised to tx. Okay, where t is in some interval and 0 should belong to that interval. Okay, which means for 0 it should be defined. So this is mx of t. Very nice. We can define anything that we want, but why are we defining it? Because firstly, we can directly calculate moments. So expectation of x raised to n is just derivative of t, or sorry, the moment mx of t taken n times and then evaluated at 0. Okay. Why does this happen? That's because if we expand this, we get 1 plus t by 1 factorial expectation of x plus t square by 2 factorial expectation of x square, etc. Okay. So as you can see, the moments are nothing but the coefficients of t square, t, etc. So it follows the same logic. Here we wanted coefficients of s, s square, s cube. It was a function of s. So we differentiated r times and then we put s is equal to 0, right? And we had to divide by r factorial because there were no factorials here. But the good thing about this one is that we already have the factorials here. So it's just the derivative of mx taken n times, and then finally we put t is equal to 0. Okay. So we can directly calculate the moments. And the second thing is that if we know that mx is equal to my, which means for two different random variables, we have the same moment function. So what this means is that mx of t is equal to my of t for all t. That's the meaning of two functions being equal. And that means that x is equal to y. Okay, so they are not really different. They have the same distribution. So this we can use to figure out whether two random variables are actually different or not. Okay, and finally we had third generating function, which is called characteristic function. And the way it is defined is that it is expectation of e to the power I tx. Okay, where I is our good old friend, square root of -1. What this does is that firstly, we don't have any problem of blow because we know that the modulus of e raised to I times anything is just 1. Okay, as long as this anything is real. So, and because t and x are real, so it does not matter. This is bounded. That's a good thing. In fact, we can show that this is always less than or equal to 1. Okay. The reason is that mod psi, sorry, so mod psi x of t, let me write it here, which is mod of expectation of e raised to itx, that is less than or equal to expectation of e raised to itx mod, which is equal to 1. So this function can never be greater than 1 in the absolute sense, in the magnitude sense. Okay, so it will have some phase, but the magnitude of this complex number will never go beyond the radius 1. Okay. Uh, yeah, I guess that's it. Uh, yeah, this will do for now. So, any questions in this, or we can jump to assignments otherwise? Any questions? Do you want me to re explain anything?
Sir, am I audible?
If not, then let's take a small break. It's 6:52. So let's reconvene. It's 7 p.m. Okay, so we have a short break of 8 minutes. You can use the restroom or whatever, and we'll be back at 7 p.m. Okay. Okay. Let's start. So I put this question on the screen few minutes back. Has anyone tried to solve this? Would anyone like to solve it? I can give a couple of minutes. Or do you want me to directly solve? Wait. Okay. Yeah, money is solving. I would urge everyone to at least try it out. Okay. It's okay to try and not figure it out. That's why we are here. But at least try it out. So I'll just explain the question in the meanwhile. We have a random variable and probability mass function is given, which means it's a discrete function. In fact, it can only take three values, 3, 4, or 5. You can always think of this as some kind of height or weight or something. So the fraction of people with height 3 is this much. What whenever you put x is equal to 3, that would be 0 by 5. So in fact, there are no such people. With height 4, we have 4 minus 3 square over 5. So 1 by 5, 1/5 of the people are height 4. And if you put x is equal to 5, that is 4 over 5. So 80% of them have height 5. Okay, in some weird units. The question is to calculate variance. So the variance is defined as expectation of x minus mu whole square. Okay. And you can also use this formula, both are identical, minus mu square, where mu itself is expectation of x, the average height. Okay. Which means first we need to calculate this quantity mu. Has anyone calculated average of x? Money. Have you calculated expectation value of x? No. Okay. Okay, then let's calculate it together. So expectation of x is nothing but sum over xi times p of xi, right? Because we have a discrete random variable. So where xi is equal to 3, 4, and 5. So it's 3 times probability of x is equal to 3 plus 4 times probability that x is equal to 4 plus 5 times probability that x is equal to 5. This is 3 into 0 plus 4 into, we put x is equal to 4, it was 1 by 5 plus 5 times probability that x is equal to 5. So put 5, which will give us 4 by 5. This is equal to 4 by 5 plus 5, which is, sorry, plus 4, which is 24 over 5. Okay. So this is equal to 4.8. That makes sense, right? Because there are none with height 3. There are only 1/5 or 20% people with height 4 and 80% are with height 5. So if you can think about this, I like to imagine it this way. So we have 20% people with this value and 80% with this value, which means our average has to be somewhere around here, close to 5. right? Because most people are with height 5. And in fact, this ratio has to be same as this ratio. So this should be 80%, which means this should be 4.8. And it checks out. We get 4.8. Okay, so nice sanity check that we can do. So this is our value of mu. Okay, now we have to find expectation of x square. So expectation of x square would be sum over x square p of x. Again, x is equal to 3, 4, 5. This would be 3 square times p of 0, 3 plus 4 square times p of 4. I'm just writing it because it's the first question. 116 over 5. Okay, we'll see. I think you must have made some arithmetic mistake because it's not in the option. But maybe it's wrong. Let's see. Maybe the options are wrong. So 5 square into p of 5. Oh, expectation of x square. Yeah, that could be 116 by 5. Let's see. So this is 3 square into 0. And this is 16 into probability of 4, which was 1 by 5. This is 5 square into probability of 5, which is 4 by 5. So this is 16 plus 5 square into 4. This is 25 into 4. 100. Yeah, so 116 by 5. Absolutely. Okay. Once we have these two quantities, variance is super easy. Variance of x is expectation of x square minus mu square, which is the square of expectation. So 116 by 5 minus 4.8 ka square. So let me write 24 by 5 ka square. 24 into 24 divided by 25. Okay, this is 24 by 5 whole square. So let's just calculate. So this, to make the common denominator 25, I need to multiply 5 here. So this will become 580. This is 24 square, which is 576, I believe. Yeah. So this is equal to 4 by 25. Okay. Excellent. Which is the fourth option. Okay. I hope it's clear. Any questions? No. Okay. Others can also reply, by the way. These are not personal coachings of anybody. Okay. Second questions. I don't want you to solve it, but I'll read the question and you give me the idea how to attack this problem. Okay. So we have two teams, A and B, India and Pakistan or whatever, in a series of independent games. And first team to register 2 wins, 2 games, and that would win the series. But A is weaker than B, so probability of A winning is 0.4, B winning is 0.6. What we have to find is expected number of games that will be played. So on average, how many games will be required? If we play thousands of series and then take average, what would it be? Okay, that's the question. So can somebody tell me what would be the strategy to solve it? The first step? You can unmute yourself and tell me. No one wants to take a guess even?
Sir, sir, AA.
Come on, I won't beat you if you give me wrong answer. Because for starters, this is an online course, so I cannot reach you. but even otherwise I wouldn't.
Sir, do you hear
But
me, sir?
okay, since nobody is
Sir.
speaking, I cannot but solve it myself.
Sir,
So,
do you hear
so
me,
just
sir?
to summarize, we have two
Hello, sir.
teams, A, B.
Sir.
Oh, you are
Sir.
trying to speak.
Yeah, trying, sir. Am I not audible, sir?
Oh,
Not audible.
my bad. I don't know. Is my speaker not active?
I think.
Yeah. Just give me one moment. I'll reconnect my Bluetooth. Okay. Can you speak again?
Sir,
Yeah.
possibilities are A will win two times.
A, right?
Next B.
B, B,
Next option A.
A, B, A,
One more option B.
B, A, B, right? Because we have to win twice.
Yes.
So if a team wins in the first two games, that's it. We go home. But if two different teams win, then whichever team wins, the last one, that is the winner. Okay, so we have these four options. So these are, and we can assign our random variable. So this is the X, right? Number of games. So what would be the value of X in the first case? How many games are played? 2 games, right?
2 games.
Yeah. So 2, 2, 3, 3. So sometimes we'll play 2 games, sometimes we'll play 3 games, but it's not with equal probability. So P of this happening is that first we have to win in the first game. So A has to win, which has probability of 0.4.
Correct.
Times also next it has to win. So again 0.4. What would be the probability of second one?
0.6.
0.6. Okay, so this is 0.36. This is 0.60.
0.16.
Okay. What would be the probability in third case?
0.4.
0.4.
0.6.
0.6.
And 0.4.
And 0.4. Excellent. Okay. And fourth one?
0.6.
0.6.
Product 0.4.
Mm-hmm.
Product 0.6 again.
0.6 again. Okay.
Sir, two more options are there, sir.
2 more options?
3 B.
Oh, yeah, right. Totally forgot about it. Thank you.
And again
A, B, B.
B,
A. Yeah. So this is also 3. In this case, I would have 0.4 into 0.6 into 0.6.
0.6.
This is 0.4 into
0.4.
0.6 into 0.4 into 0.4.
0.4. Correct.
Right. So probability that X is equal to 2 has to be 0.16 plus 0.36, which is 0.52. Okay. So probability that only 2 games will be played is slightly more than 50%, 52%, which means the probability that X is equal to 3 is 0.48, because total probability should be 1, right? And you can calculate it explicitly. Okay. So now it's very easy. We have to find expectation of X, which means it is sum over X. We have discrete variable. x into p of x. So when x is 2, let me remove the sigma sign. So it will be 2 times p of 2 plus 3 times p of 3. Okay, we can either have 2 games or 3 games. So this is 2 into 0.52 plus 3 into 0.48. So this is 1.04. This is 1.44, I believe. That would be added to 2.48. Okay. So on average, we play slightly less than 2.5 games. Okay. Why? Because probability of 2 games is slightly more than 50%. So again, we can use the same logic because we have just 2 variables, 2 and 3. For 2, we have 52% chance. For 3, we have 48% of chance, which means our number would be slightly towards 2. And this ratio would be 48 is to 52. Okay, which means this has to be 2.48, which is what the answer turns out to be. Okay, so the correct answer is C, something in between. Exact answer is 2.48. So probably you will have this kind of questions with some blank in assignments where you can put your answer. So, and in general, the correct solution, the solution set that they will have some range 2.4 to 2.5. So even if you make last digit error, it's generally okay. All right. So if you have any questions, just ask me. Third one, is anyone trying? Third one?
No, please.
Yeah.
Please just interpret the answer, interpretation. Just I got the mathematical procedure. It's okay. No doubt about it.
Yeah.
Just interpret and back to apply to the problem.
Yeah. So let's read the question again. It says that we have 2 teams, and whichever team wins 2 games wins the series, which means we can at most go to 3 games, right? It's a best of 3 kind of a game. But if some team wins the first 2 games, then it's over because then we don't need the third one. It's
Third game,
optional,
yes.
right?
Yes.
So it could either be 2 games or 3 games. So on average, it is going to be between 2 and 3. Now, so for that, we need to know what is the probability that it is 2 games. And that turns out to be 52%. And probability of 3 is 48%. Now, if they were 50-50, then we can say that average would be exactly in the middle, 2.5. But because 2 has slightly higher probability, this number is slightly going to shift leftwards. And we can exactly calculate it. It should be in the same ratio as these probabilities, but inverted. So towards 2, it should be 48, and towards 3, it should be 52, right? And so what is the number that divides 2 and 3 in this ratio, 48 to 52? That is 2.48. Okay. All right. Okay. Should we proceed?
Yeah.
Okay. Third one. Let me just recite the question. The probability generating function is given, which means it's a discrete variable. G of s is this thing, whatever it is. Mod s is less than 1, and we have to find the expectation. So, is anyone trying?
Yes, sir.
Okay, 2 minutes. So I'll just write down the formula in case somebody does not know. It is G prime of 1.
Sir,
Yes.
expectation of x is equal to lambda.
Yeah, lambda. Okay.
If you put the s is equal to 1,
Mm-hmm. Yeah. So, can you tell me your reasoning? Expectation of x is g prime of 1
g right, 1
and
is equal to
is equal to.
e to the lambda.
Mm-hmm.
S is equal to, then s is equal to 1 is equal to 0. E to the power 0. 1 minute.
No, you have to take a derivative first.
Differentiation.
Derivatives, right.
Yeah. Yeah.
That is lambda e to the power lambda into s minus 1.
Okay. And then put s is equal to 1.
Is equal to 1, right.
So this
Lambda is equal
becomes
to
lambda.
uh,
Yeah. Excellent. Okay. So it should be this lambda.
lambda.
Is
It is a
everyone
Poisson
convinced?
distribution, sir. Sir, it is a Poisson distribution.
I think Poisson involves factorials, if I am not mistaken. Let me check, maybe. Let me
Yeah,
quickly
Poisson, it is Poisson random variable.
Is it? I think. Okay. Oh yeah, this
Yeah.
is the moment generating function. Right, right. Then you are right, right? It is Poisson. Okay, nice. And as you know, that expectation of this is lambda for Poissonian. Okay, then let's move to the fourth one. What is the difference between? Oh, I use it just randomly. Some people like this bracket, others use this bracket. Yeah, yeah, it's same thing. I think in course the professor is also using the curly this curved bracket, simple brackets. But in generally people use square brackets for expectation. But there is no difference as far as this course is good. Okay. Fourth one. Again 2 minutes. I hope you are solving. Again, I will just write down the formula. Mx of t is expectation of e raised to tx. Okay. This is equal to e raised to tx times fx dx.
Sir, it is B1. B. Answer is B.
B. Okay. Yeah. I
We
think you are
integrate
right. Yes. Can you tell me the procedure?
integration minus 2 to 2
Mm-hmm.
e to the power tx into 4 into 1 by 4.
1 by 4, which I can take out.
Yeah.
Yeah.
Then integration of this is e to the
Mm-hmm.
power tx upon t.
E to the power tx upon t. Right.
Uh,
From minus 2
minus
to
2
2.
to 2.
Mhm.
Yeah.
Yeah.
Then put the value of this x.
Should I put x is equal
Uh,
to 2 or t is equal to 2?
First, x is equal to 2.
X, right? Because x is being integrated. So
E
I
to the
get e
power
raised
2t
to 2t minus
minus
e to the
e
power
to the power
minus 2t
right
divided by t.
upon t.
Yeah, perfect. So that is option B. I think others also found, right? Yeah, B, right. My bad, x is equal to 2. Yes. Awesome. Good that all of you are trying, or at least some of you. Okay. Fifth one. So fair die is thrown, which means all the numbers have equal probability, 1 through 6. But it's thrown twice and the scores are summed, right? Kind of thing we do in some of the games. And x is the sum of those two. So if I roll 2 and 5, then I use 7. So what is the expected value or the average value of the sum of those two numbers? So without doing any calculation, just looking at the options, can you tell me which one is the correct one? Is anyone trying or not? 7. Yes, it seems correct. Can you tell me the reasoning?
Sir, the results can be from 2 to 12
Yes.
and all are
X.
equally likely. So the middle one is.
Okay. So 5, 6, 7, 8, 9, 10, 11, 12. Okay. So that's what I was saying that if you look at the options, there is only one option which is between 2 to 12. I mean, there is 12 also, but that is extreme one. So it cannot be the average, right? So if there is a correct option here, it has to be 7. Now, whether it is all of them are equally likely or not, let's just see. Let's say A is on the die number 1, the number you get on that, and B is die number 2. And A is that is true, that equally likely. So I can get 1, 2, 3, 4, 5, 6. And this is also 1, 2, 3, 4, 5, 6. All of them have equal probability 1 by 6. So if I make a table of A versus B, this could be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And each of this square is equally likely, right? For example, I can get 5 here and 3 here. That would be this number. Okay. So if I get 1 and 1, then the total would be 2. If I get 1 and 2, then the total is 3. 1 and 3, total is 4, 5, 6, 7. If I get 2 and 1, then the total is 3. That way 3, 4, 5, 6, 7, 8. Okay. And now you can see the pattern. Everything shifts leftwards. So 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. Do you still think I have the same chance of getting 7 as getting 2?
Yes, sir. Chances for 7 is more than 2.
More, right? Because there is only one way I can get 2 if I roll both of them 1. Whereas for 7, I can have 6, 1, 2, 5, etc. Okay, so now if I calculate, the total there are 36 possibilities. So for 2, we have just one chance, 1 by 36. For 3, we have 2 possibilities, 1 comma 2 or 2 comma 1. So 2 by 36. Okay, similarly for 4, we have 3 by 36. So it keeps on increasing till we reach 7. So for 7, we have 1, 2, 3, 4, 5, 6, 6 over 36. Okay, then for 8, again, I have just 1, 2, 3, 4, 5. 5 over 36, so it decreases. Okay, so the highest chance is for 7. You are most likely to have a total of 7. For 12, it's 1 over 36. Why? Because you have to roll 6 and 6. Only one possibility. Okay, so if we look at the distribution of x, here we have 7, 6, 5, 4, 3, 2, 8, 9, 10, 11, 12. And 7 has the highest chance. So this is P of x. And 8 has lower chance, 9 has lower chance, etc. Okay, this is not to scale. And it is symmetric, by the way. Okay, so we have the highest chance here. And because it's symmetric, we can say that the average value is 7. Okay, and if you don't believe me, you can just do expectation of x, which is sum over x p of x, where x starts from 2 to 12. And you will find that this is actually equal to 7. So on average, you are going to roll 7. You can roll higher or lower, but both of them have equal probability, which is why 7 is the average score. Okay.
सर इसको ऐसा भी इंटरप्रेट कर सकते हैं क्या? दिस फॉलो द नॉर्मल डिस्ट्रीब्यूशन, है ना, और एक्सपेक्टेशन एज इज मीन, है ना?
Yeah, I think
In
so.
normal distribution,
It seems
median mode
normal.
are equal.
Yeah,
Mean
but
median mode are equal. This
no,
is
you
the
are right.
median part.
It looks like normal, but it is not exactly normal. Because for normal, you need, firstly, normal is for continuous. We have discrete. But even if you write it something like this, it's not following this kind of thing, right? Dx is not exponential of x minus mu square, because that would look like this, then increasing, then decreasing, right? Whereas in this case, we have linearly increasing and then linearly decreasing. Okay, so it is not normal, but you are right. It's still symmetric, just like normal distribution. It's just that it's a triangle distribution, if you want to call it. But because it is symmetric, the exact middle value is going to be your average. Okay.
Okay. It's yes,
Yeah.
it's a discrete distribution, right. Okay.
Yeah. But good observation. Okay. Let's go to 6th one. This is slightly tricky. If you want to solve it, you tell me. Otherwise, just tell me the strategy to solve it. So we are given a moment generating function, which means it's a continuous variable, which looks something like this. Okay. Some sum of exponentials with some coefficients. And we have to find the probability that our x lies between this range, mu minus sigma and mu. And you can take a look at the notes. We have never this kind of inequality. And we need the exact value of p, so we cannot use any of those inequalities. So what to do? Any ideas, suggestions?
So do we find two different, like for example, mu minus omega, sorry, not sigma is t, and then mu is also t, and then we can find those and subtract them, and then we can come at this, something like that.
Right. That's a nice idea. So what you are saying is that first find probability of x less than mu, and then subtract probability of x less than mu minus sigma. This would be equal to what we are asked, right? This is exactly correct. Only issue is that how do you find this? Because all inequalities tell us that it is greater than or equal to or less than or equal to, right? Same for this. But what we are asked is to find the exact value of this.
So since this is a continuous function, does it matter that we have equality sign or not?
No, it's not about equality, but we have inequality, right? So it matters. Yeah. And sorry, I misspoke. It need not be continuous function. It's just that this function itself would be continuous, mx of t as a function of t, but the random variable could be discrete.
Right.
Okay. And to see that whether it is discrete or not, we can explicitly find it. That is the trick here. If you have seen the lectures, then you would know that he has also done one example. So let's do one example before solving it. Let's say I have a discrete variable. So x can take with 5. And the probability of this is 1, this is 3, 4. Okay, this is probability. Then what would be the moment function?
And create.
Oh, it's good. Which is also correct. Let me see. Sorry, is it visible now?
Yes, sir.
Hello, I think I can't hear you. Can somebody speak? And
Hello. Yes, sir.
the speaker is not working.
Yes, sir.
I don't know. Really sorry about that. I'll make sure this does not happen. Is it okay now?
Sir, we are able to hear you.
Yeah, okay. Now I can also hear. Okay, so what I was saying was that if we have a discrete random variable, let's say x can take only 2 and 5, two values with these probabilities, then what would be the moment generating function? That would be expectation of e raised to tx, which is nothing but e raised to t small x times probability of x sum over all x's, which in our case is just 2 and 5. That would be so not some, e raised to 2t times p of 2 plus e raised to 5t times p of 5. Now p of 2 is 1/4, so 1 by 4 e raised to 2t plus 3 by 4 e raised to 5t. Okay, so what we notice is that these are our random variables, so the values it can take, and these are the probabilities. Okay, if we have this kind of moment generating function. So similarly, we can see that we have some exponentials with some coefficients sitting in front of them. This is e raised to 0, by the way. So which means this is the probability of 0, this is the probability of 1, this is 2, and this is 3. Okay. So in our case,
You are not audible.
so, oh, I'm not? Okay. Am I audible now?
Yes.
Okay. Yeah. So in our case, p of 0 is this number because it is e to the power 0t. That's the coefficient is 1 by 6. P of 1 is the coefficient of e raised to t, which is 1 over 4. P of 2 is what is sitting in front of e raised to 2t, which is 1 over 3. And P of 3 is what is sitting in front of e raised to 3t, which is 1 over 4. And you can see if you add all these up, you will get half plus half, which is 1. Okay, so this is the correct distribution. Now what is asked is, what is the probability that x takes value between mu minus sigma and mu? So we have to explicitly find what is mu and what is sigma. So can somebody calculate with me what would be the value of mu, the average? It will be 0 times 1 by 6 plus 1 times 1 by 4 plus 2 times 1 by 3 plus 3 times 1 by 4.
Okay. That is 5 by 3, sir.
5 by 3.
3.
Okay. Plus 3 by 4. Yeah, sounds correct. Okay, so I'm just taking your word for it. If answer doesn't match, then we'll try again. But yeah, mu is 5 by 3. 5 by 3 is what roughly in decimals?
1.67.
1.67, right? Okay. Now we need to find sigma. Sigma is square root of variance. Okay, so variance of x is again expectation of x square. So it's same thing as this one. But instead of 0, we write 0 square into 1 by 6 plus 1 square into 1 by 4 plus 2 square into 1 by 3 plus 3 square into 1 by 4. Have you calculated this?
Yes, sir.
Okay.
That comes P of x square 23 by 6 it comes, sir.
23 by 6.
6.
Okay. Yeah. Which is equal to roughly 3 point something, right? 1 by 6 is 0.17. So 3.83 sort of a thing. Okay. So now sigma, variance of x is this minus mu square. So this minus 1.67 square.
That is 1.056.
1.056, yeah. So very close to what? This is our sigma.
That is sigma square.
But it does not matter. Even sigma would be very close to what?
1.0274.
Yes, right. Okay. Which means we are told to find probability that x is between mu minus sigma. So 1.67 minus 1. So 0.67 and 1.67. Right?
Yes.
Now x can only take these values 0, 1, 2, 3. And what we are asked is to find the probability that it is between 0.67 and 1.67. So x can only take value of 1, which is 1 by 4, the probability of it. Which is why the correct answer would be 0.25. Okay. Does it make sense, or do you want me to re-explain it? Anyone?
Yes, sir. Explain again.
Explain again. Yeah. So what I was saying initially is that this is sort of a deceptive problem in that we are given mu minus sigma and mu. We have to find this probability. So we would think it requires some Jensen's inequality or Markov's or something, but it is not like that. We have to calculate it explicitly. First, find the distribution of x. Now, how do we find the distribution of x? That is by looking at this moment generating function, and we notice a pattern. The pattern is that we have some coefficient, then exponential of t. Coefficient, exponential of 2t. coefficient exponential of 3t. And this is also coefficient exponential of 0t. Okay. So whenever we have that, as we saw, it means we have a discrete random variable with these values. So whatever the exponential is, so this is x is equal to 1. So this will be probability of 1. This is x is equal to 2. This is probability of 2. This is x is equal to 0. So probability of 0. And this is probability of 3. Okay. So now we have the exact distribution, everything that is needed. So once we have the probability distribution, finding mu is just algebra, right? So we can find the mu as sum over x times px, where x would be from 0 to 3, right? And similarly, we can find variance and the square root of variance, which is sigma. So that turns out to be 1 and mu turns out to be 1.67, which means what is asked is that probability that mu minus sigma, which is 0.67, is less than x less than 1.67. Okay, so x has to be between 0.67 and 1.67. But we know that it can either take value 0, 1, 2, or 3. So only value of x which is possible in this interval is just 1. And what is the probability of x is equal to 1? That is this number, 1 over 4. Okay, which is why the answer is 1 over 4. Okay. All right, then let's move to the next question. The 7th one. This you can solve using Jensen's inequality. So we have a batch of 100 students that can score between 0 and 100, and average is 51, right? Very close to 50. And give an upper bound on the probability that student scores over 85. So let me just translate it into language of math. We have to find probability that x is greater than or equal to 25, but we have to find an upper bound, so maximum value it can take, which means this is less than or equal to what? This value we need to find. So what is the Jensen's inequality? Probability of x greater than or equal to t?
Sir,
Yes.
we found upper bound that is less than equal to or greater than equal to.
Upper bound means less than or equal to. Like upper bound of your height is 6 feet, which means that at max you can be 6 feet, which means height is always less than or equal to 6 feet, right?
Okay, sir.
Mhm. So can anybody tell me this inequality? What is on the right hand side?
E of x by t, sir. Markov's inequality.
Yeah, Marcos. Sorry, I said Jensen. So sorry, it should be Marcos. Okay, so here we have t is equal to 85. So this is equal to expectation of x divided by 85. What is the expectation of x? We are given 51 divided by 85. So 17 3s are 51, 17 5s are 85. So this is 3 over 5. Okay. Is it clear? By the way, again, we can do intuition. Don't have much time, but very quickly. So what we are given is that we have this scores, right? 0 to 100. And 85 would be somewhere around here. And we have scores like this, distributed everywhere. But what we are given is that the mean value is this one, 51. Okay. And what we are asked is, what is the maximum probability or maximum number of students which can score more than 85? Okay. So let me erase this. So we have 100 students. Can all 100 score more than 85? No, because if all of them score more than 85, then the average would also be more than 85. But we are given that average is 51. So not all 100% can give more than 85. So let's say that out of capital N is equal to 100, we have some N that gets more than 85. So their average would also be greater than 85. Let's call that average some X star. Okay. So if I want all of them maximum number of students to score more than 85, then all the remaining should score 0. Okay, to maximize this number N. In that case, average would be N times number of students times the average of this. Okay, which is more than 85. So let me write X star. Okay. So instead of N, let me just write P, which is the probability. So N by N is our probability. So P into X star plus all the average of these 0 scores, which is 0. This is equal to 51, which means P is equal to 51 by X star. And X star is greater than 85, greater than or equal to, which means 1 over X star would be less than or equal to 85. Again, we get 51 by 85, which is 3 by 5. Okay, so it's exactly same as proof of Markov's theorem. Okay, the 8th one. So I think we don't have much time, so let me solve it myself. You can do it in parallel, of course. But we are given a random variable with mean 1 and variance 1, and we have to find a bound on this. Okay, so probability that X is greater than or equal to 3. And we know that same is saying X minus 1 greater than or equal to 2. Right? Why am I writing like that? Because we know that 1 is mean. So now I can use the second one. What is called? I forgot the name. Yeah, Chebyshev. Oh, it was written here. Silly me. So the statement is that probability that X minus mu, mod of X minus mu is greater than epsilon as the upper bound of variance divided by epsilon square. Okay. So firstly, I don't have mod, but if I put mod, then I am only increasing the probability, right? Which means this is less than or equal to that, because I am including some more cases, even though I don't need to, but I only want to find the upper bound. So it should be mentioned, by the way, here, upper bound. Okay, and now I can use this inequality. So this is our mu, and this is epsilon. So this is equal to variance divided by epsilon square. Variance is 1, epsilon is 2. So 2 square, which is 1/4. So the answer is 1 over 4. So if I have any distribution which has mean at 1 and variance is also 1, then the probability that X is greater than 3, which means this area could at max be 1 over 4 or 25% of whole thing. No matter what distribution you cook up, it is mathematically impossible to have more area than 1 by 4 this way. Okay, that's a statement. Okay. The ninth one, again similar thing. We have been given this random variable. Mean is given, variance is given, and we have to find the lower bound probability that x by 100 differs from 0.50 by less than 0.2. Okay, the probability that mod x differs, meaning in either way. So mod of x by 100 minus 0.50 is less than or equal to 0.2. Okay, and we have to find the lower bound, which means it is greater than or equal to what? So first thing we should do is invert this. 1 minus probability of mod x by 100 0.50 greater than or equal to 0.2. Okay, because these two are complementary events. The total sum is 1. And now let me rewrite this so I can multiply 100 both sides. So x minus 50 greater than or equal to 100 times 0.2, which is 20. Okay, this is our mu, which means I can write. So this would be greater than or equal to 1 minus, and this was variance divided by epsilon square, which is 1 minus variance. Variance is 25 and epsilon is 20, so 20 square. So 1 minus 25 by 400, and this is 1 minus, I can divide by 25, so 4 4s are 16, so 15 by 16. Okay, so this is the lower bound. Any questions?
Sir, variance 50 or 25?
Variance is 25. Mean is 50, variance is 25.
Yes, sir.
Okay, yeah. Final question. After that, you will be out of jail. So, and it's very easy. Which of the following statements are correct regarding characteristic function? So just remember, phi of t was given as expectation of e raised to itx, right? And we saw that this is less than or equal to, so mod of phi t was less than or equal to expectation of mod of e raised to itx, and this is 1, which means this is also equal to 1. So mod of phi t can at most be 1. So can it be 3 for some x? No, it can't be, right? So this is wrong. These are all R, I think. So this is wrong. Phi of 0. Let's calculate phi of 0. It is expectation of e raised to 0. This is expectation of 1, and 1 is constant, which means it is just that constant. So this is correct. Phi x less than or equal to 1 for all x. Is that correct? Anyone? Is the third one correct? State. So this t is just dummy variable, right? I can write x also. Mod phi of x less than or equal to 1, which means phi of x can be from +1 to -1 between these two values. Okay, it can't be -2, for example, because mod would be +2, which is not allowed. But anyways, phi x is always less than or equal to 1, which means this is correct. And the final one, phi of 0 is, as we saw, it is 1. So this is also incorrect. So B and C are correct ones. Okay. Any questions?
Sir,
Yes.
some of these questions are not there in the assignment given.
Okay, so ideally there should be no questions given in assignments because these are from previous year's assignments.
Right.
Okay. It's just that the course, whoever designed the questions are lazy and they are repeating the questions. So the questions you get in assignments are kind of gift for you because now you have the correct answers.
Yeah.
But yeah, ideally they should not have any overlap. Okay. Anybody else? Any questions, comments, feedback? If not, then let's say goodbye. We'll meet at the same time next week.
Okay.
Bye.
Thank you.
Bye bye
Good
everyone.
system.
Thank you.
Very,
Yeah.
very good system. Okay, right.
Yeah. Good night.